Hey everybody, today we're going to be taking a look at the words relation and function today, a little bit closer look at those things. And you're going to need your notes and a pen or pencil, of course, to write in your notebook as we write down some keywords and some examples. So some keywords that we need today. The first one is relation. And a relation is simply a set of points that consist of input values, which we usually label with an X, and output values, which we label with a Y. And these sets of points can be viewed or shown in many different ways. They can be viewed as ordered pairs, which we would put on a graph, or they can already be graphed themselves. We can have them still in a table. We can even write it as an equation, or written in sentence form if we wanted to get a little fancy. So this idea that a relation of x's and y's and how they're shown there, that's something that we've been working with most of this year and we will continue to work with. Now, in our sets of points, or in our relations, we have domain and range values that we've been looking at. So it's time to sort of remember what those words mean. Remember, the domain means that we're talking about all the x values, and the x values are representing the inputs. And the range is all the y values, and those are the output values. We've talked about this quite a bit this year already. Let's take a look at an example of a domain and range if we're talking just about a relation. So not a graph, not a whole equation, but just about a relation, a set of points here. This finite set of points is the one that we're looking at, this example. Go ahead and write this one down. And here's the set of points that we have. The bracket at the beginning here starts it. We have the point 0, -6, 2, -3, 4, -1, 6, 0, 8, 1, 10, 10. If I were to identify the domain, what would I be looking at? I'd be looking for all of the x values. And if I was looking for the range, I'd be wanting to make a list of all the y values that are in this set of points. So simply, I'm looking for all the x values. And all the x values come first in these points. So if I make a little list, you see down below, 0, 2, 4, 6, 8, 10, those are all the numbers that are the x values in this set of points. So using the same logic now, what are the y values going to be? And I just make a list of those y values. So -6, -3, -1, 0, 1, 10. Notice in my list that they go in increasing order, okay? So that they're in lowest to greatest order here, least to greatest. And I'm making a list of those values. So the next thing we need to remember is this whole idea of functions. Functions, we use that word quite a bit. What does that really mean? A function is a relation, so it's one of those x-y relationships where every x is paired with one unique y value. This is very important. We've been talking about linear functions, absolute value functions. So every time we talk about the word function, what are we really meaning? What are we really saying? We're saying that it's a special relation where every x value is paired with one unique y value. So in a set of points, for example, let's write this one in our notes, is this set of points representing a function? Here's the set of points right here. And if I want to know, I need to know that every x is paired with just one y. So this is an x value of 0 right here. 0 is paired only with -6. If I look at all the other x values here, 0 is not paired with anybody else, okay? There's no other zeros for an x value, so that doesn't mean he has another partner for a y. So all of those x values that you see here, none of them can repeat in our list of points. We need to make sure that they're all special and unique and then they're not listed twice, because if I did have another one, 0, -2, let's say, that would make this guy not be a function because 0 can only be paired with -6, nobody else. So is this set of points a function? The answer is yes, and I would write that in my notes. 0 is paired with -6, 2 is only paired with -3, and so on. So if we took a look at another example to sort of illustrate what isn't a function, here I'll erase, and then I'll show you that set of points. You would want to write those in your notes as well. Here's another set of points. Is this a function? Now remember, like that last one, we went through and we said, okay, -1, you're only paired with -7. 1, you're only paired with 0. 2, paired with -3. 0, paired with -8. 0, 0 is paired with 5 as well. This is bad. Okay, 0 can't be paired with two different y values. He has to only have one unique y value. And because that's happening, this is not a function. Okay, so this is an example of not a function. So when we plot our points or when we look at a list of points, that's what we're going to be looking at to see if they make a function. What if it's already graphed and I don't want to make the list of points to try to check that whole x paired with one y business? That's where this vertical line test comes in. And you would want to write this part down too. The vertical line test is a fast way to check if something is a function, especially when you have a graph already. So the vertical line test says a relation is a function if a vertical line drawn through its graph passes through only one point. So rather than make a big list of points for the whole graph, which could take a long time, we can pass a vertical line, that's one that's up and down, through a graph and check to see that it's passing the test, okay? If it passes the vertical line test, then it is a function. Let's take a look in a minute here. We're going to kind of take a look at an example. I always like to use the pencil whole idea. So if I'm using the vertical line test, I will take my pencil and I will hold it vertically across the graph and I'll move it from left to right and see if it crosses in more than one point. If it does, it's not a function. If it only crosses in one point at a time, then it is a function. So please get this whole part in your notes here. The pencil idea is a handy one. You can also use your finger or a ruler or whatever else you have. So example, maybe sketch this in your notes. Just draw the axes and a quick line like this. You don't have to number it if you don't want to. But the idea being, would this graph be a function? Rather than make a list of points, well, 1, 1, and 2, 2, and, 1.5, 1.3, rather than make that list of points that would be on this line, we can just use the line itself and pass a vertical line. Vertical line, like a pencil. If I pass this vertical line across that drawn line, see it hits in one place there, and just one place there, it never hits the pencil in two places at the same time. And because of that, I would say, would it be a function? Yeah, it passes the vertical line test. A vertical line only hits it in one place at a time. Whereas this example, circle here, or an oval, or in this case an ellipse, go ahead and draw that on your graph paper. Would this graph be a function? Well, if we take that vertical line test, that pencil, and we pass it over the graph like so, it hits in one place there, but uh-oh, as I pass the pencil across, I see that it's hitting in two places at the same time. Not good. So we would say, no, this graph is not a function. It does not represent a function. Okay? So the whole idea of a vertical line test and understanding the vocabulary, relation, function, domain, range, that's where we want to start here as we continue to build our knowledge of functions. So thank you for taking good notes, and I will see you later.